Good morning, class. We are looking at exam 4 review, chapter 4, application of differentiation, chapter 5, integral, 6.1, areas between curves. And here's part of 5.5, the substitution rule, and 6.1, areas between curves. So we are dealing with the substitution method. As far as the substitution is concerned, you look for a function and its derivative there, and you let that function be the u or g of x. Anytime ln x is involved, that is the choice of u. You know the derivative of that is 1 over x. Therefore, du is 1 over x dx or dx over x. It's a good practice to rewrite it in a manner that it becomes clear what we are dealing with. So I'm going to write this as ln x to the second power. And then this part, you can write it as dx over x or 1 over x dx. Either way, you notice this is u squared times du. And the answer is 1/3 u cubed plus a constant. U is replaced by ln x. We are done. It's important not to mix up ln of x to the power of 3, which means ln x times ln x 3 times, versus ln of x cubed, completely different animal. So whenever you have a fractional format, the very first step is to simplify, put it in lowest term if you can. If you cannot, ask yourself, if I choose the bottom to be the choice of u, and normally that's the case. Notice the derivative of this, e to the power of x is itself, and e to the power minus x is e to the power minus x times -1. So if you choose u to be the bottom, the top is its derivative, the top times dx becomes du therefore. So u is the denominator, e to the power of x plus e to the power minus x, and du is e to the power of x minus e to the power minus x. And so now you are looking at, if you put the dx, remember dx, it always belongs to the numerator. So you're looking at du over u, which is a simple case of a natural log. And you're going to replace the u, you get ln of absolute value of e to the power of x plus e to the power minus x plus c. Because the expression is always positive, if you change it to a parentheses, that's fine. So again, you don't have to, but it's good to recognize it's positive. Now, the integral of 3 to 4, x squared of 25 minus x squared, we want to deal with that, and that is a definite integral which results in a number. So you have a polynomial here, you have a polynomial under the radical, and remember what we said, the more complicated one, the more complicated polynomial is a choice of u, so 25 minus x squared is a choice of u. Its derivative is -2x, therefore du is -2x dx. We move things around by putting x next to dx. Remember, as I mentioned, in many texts, they solve for dx. But anytime a number is missing, a faster and easier way is to put that number in and undo it with its reciprocal, because you can only do that to numbers, okay? The product of these two is 1, and that's an acceptable operation. So what do you have? -1/2 square root of u du, and I'm not going to put the limits yet because the limits that we have originally pertain to x, variable x, not u. We will discuss that in a moment, but for now, we've seen this many times before. We're going to write it as u to the power 1/2. This -1/2 remains. To integrate this, we put 1 over 1/2 plus 1 u to the power 1/2 plus 1. Again, I'm not writing the limits yet. This is 1/2 plus 1, making it 3/2. Its reciprocal is 2/3. The product of these two is -1/3. You can replace the u with 25 minus x squared and put the original limits. However, I can put the lower limit in here. X squared becomes 9. 25 minus 9 is 16. I can put the upper limit here, x squared becomes 16, 25 minus 16 becomes 9, and now I'm in business. So I can use those limits. So I'm going to keep the negative 1/3 out, and I'm going to plug in 9 and 16 as follows. Now this is basic math. 9 to the power of 3 halves means square root of 9 cubed. This is 3 cubed, or 27, minus square root of 16 to the third. That's the meaning of this. And 4 cubed is 64. The result is negative 37. With negative 1/3, their product is positive 37/3. Again, we are dealing with a natural log. Anytime natural log is involved, that's a choice of you. The derivative of this is 1 over x plus 1 times 1, because of the chain rule, it doesn't, the derivative of x plus 1 is 1. So the derivative is 1 over x plus 1 makes du 1 over x plus 1 dx. Again, we rewrite it so it becomes clear. You're just rewriting it. Remember, dx always belongs to the numerator. So it becomes clear that you have u du. And I'm not going to write the limits yet. Of course, the integral of u is half of u squared. But what are the new limits? You can go back to the original one, or if you want the new limits, you put the 0 in here, you get ln1, which is 0. You put 1 in here, you get ln2, which is ln2 precisely. In calculus, we use the exact answer. So you plug in ln2, this gives you 0, therefore half of ln2 to the second power. And you keep it as such, it's an exact answer, everybody. Evaluate the integral of negative 2 to 2 x to the power of 6 plus 1 dx. I want you to notice that when you have a function which is an even function, the integral of minus a to a f of x dx is 2 integral of f of x dx from 0 to a. And if it's an odd function, the integral of minus a to a f of x dx becomes 0. So the integral of symmetric functions f is continuous on negative a to a. If f is odd, f of minus x becomes minus f of x. So the integral of minus a to a f of x dx is 0. The reason is because this area is equal to this area. This is positive, this is negative, they cancel each other. This area is equal to this area, so it's easier to calculate 0 to a and multiply it by 2. So if f is even means symmetric with respect to the y-axis, odd means symmetric with respect to the origin. So f of minus x equals f of x, then the integral of minus a to a f of x dx is 2 times 0 to a f of x dx. And because this, of course, you can evaluate this. Just the way it is, it's not a big deal. But we are going to show that we can go from 0 to 2 and multiply it by 2 because this function is an even function. So we need to show this. And if we show that, then we can use, instead of negative to 2 as the limits, we use 0 to 2 and multiply it by 2. Why is that the case? It makes it a tad easier for the calculation. So let's look at this. First and foremost, your function is this. This is f of x, everybody. So f of minus x is minus x to the power of 6 plus 1, which is x to the power of 6 plus 1, which is equal to f of x. We just proved that, therefore we can use it. Of course, that's an easy integral is 1 over 7x to the power of 7 plus x. And if you plug in 0, that the reason you want to go from 0 to 2 is because 0 makes it easy. 0, plug in just 2. And when you plug in 2 to the power of 7, 128 over 7 plus 2, and the 0 has no bearing. And so we get 284 over 7. You multiply this one by 2, and then you add 4. And 4 is 4 times 7, 28. So we get 284 divided by 7. If we wanted to evaluate it from negative 2 to 2, this would be negative 2, and it would take a little bit longer. For a function the integral of -1 to 1 tan x over 1 plus x squared plus x to the power of 40x. For this function, this becomes 0. Why is that? Because this function is an odd function, and we follow this theorem. So we have to show this function, which is tan x over 1 plus x squared plus x to the power of 4. We have to show it's an odd function. To do so, we are going to evaluate f of minus x. So replace the x with minus x. When you replace the x with minus x, notice this doesn't change. This doesn't change. Tan of minus x, everybody, is minus tan of x. So replace the x with negative x. The denominator remains unchanged. Tan of minus x. So the numerator becomes tan of minus x minus tan x. So that means f of minus x is minus f of x. We proved f of x is an odd function, and therefore this answer is 0. Breathing. We can model the rate of airflow into the lungs by the function f of t equals half of sine 2 power 5 t liters per second, where t is the time in seconds. Find the total amount of air inhaled in one cycle, known as the tidal volume, if the cycle lasts 5 seconds. What you really should recognize, inhaling and out, the time for inhalation is half of the cycle. So if the total time is 5 seconds, the time it takes for inhaling is only half of that, 5 halves of seconds. So total amount of air inhaled follows the accumulated change, and then we take the integral of 0 to 5 halves f of t dt, which means 0 to 5 halves. We put the formula half of sine of 2 power 5 t dt, and we are going to evaluate that. We need to use a substitution method. We let u represent 2 power 5 over t. The derivative is 2 power 5, therefore du is 2 power 5 dt. I'm going to rewrite this in the following manner. Number one, I'm going to put the 1/2 out. This number is inside or outside. The integration sign makes absolutely no difference. So I have the sine 2 power 5t, or sine of u. And then I'm looking for du, and I don't have it. What do I have? dt. So what is missing? 2 power 5. 2 power 5 is a number, everybody. So if I plug in 2 power 5, it's reciprocal 5 over 2 pi. Will take care of the business. So now I'm in business. I am looking at sine of u du. I'm not going to put the limits yet. And this is 5 over 4 pi. Notice this is 5 over 4 pi. This is sine u du. The limits are not the old limits. What are the new limits? I'm going to discuss that in a moment. So this is 5 over 4 pi. Sine, the derivative is cosine. The integral is negative cosine u. So what are the new limits? If I put 0 instead of t, I get 0. So it doesn't change. But if I put 5 halves instead of t, I get 2 pi over 5 times 5 halves, and I end up with pi. So the lower limit remains at 0, but the upper limit is pi. I can keep this negative sign out. So minus 5 over 4 pi, cosine of pi minus cosine of 0. We had done this before. You should know cosine of pi is -1, minus cosine of 0 is +1. These two add up to -2. So we have 10 over 4 pi, or 5 over 2 pi. That's a precise answer. You should show the precise answer. And then if you want to go with the approximation, because this is an approximation, this is an application case, so that's fine, 0.796.80 liters. And the units liters per second, so this is liters, but it's an exact answer. You always show the exact answer to be on the safe side. We want to take the integral of x sine x squared and sine squared x cosine x. I want you to see them side by side so you see how we deal with sinusoidal functions. When we have an argument that has an exponent, everybody, the argument is a choice of u. You know the derivative is 2x, so du is 2x dx. So I'm going to move things around. I'm going to move x next to dx to make it clear that this is sine of u, but this is not du, and what's missing is 2. Again, in many texts, they solve for dx. You don't have to. This is just a number. Plug in 2, undo it with 1/2. You can do that with numbers only. So we have sine u du, 1/2 in front remains. You know the derivative of sine is cosine, but the integral of sine is negative cosine. So it becomes negative 1/2 cosine u plus a constant, and u is replaced with x squared. As always, if you differentiate the final answer, you get this thing without the dx. Now, what's the difference between a and b? In the case of b, when we have sine and cosine, both of them, the one which has the exponent is the choice of u without the exponent. Sine has the exponent, we choose it as u. Its derivative is cosine x, du is cosine x dx, my apologies, and now we are dealing with the integral of u squared du, and that's a simple case of a power rule, 1/3 u cubed plus a constant, so 1/3 sine cubed plus a constant. What if we had cosine, the integral of cosine to the power of 20 x sine x dx? Cosine has the exponent. Cosine is the choice of u. Du is negative sine x dx. So notice this one needs a negative sign, doesn't have it, so you can put a negative sign here, negative sign out. I hope you recognize that we need the negative here. This negative will undo that negative. And so what you're dealing with is the integral of u to the power of 20 du, which is negative 1/21 u to the power of 21 plus a constant, and u is replaced with cosine, and we're fine. Again, I think it's important that you see all three side by side, compare and contrast. As always, differentiate the result, you get the same thing without the dx. Integrate tan x dx, you should recognize it as sine over cosine. And anytime you have a fractional format, you try to put it in lowest term. If not, the denominator is a choice of u. You know the derivative of cosine is sine, negative sine. So du is negative sine x dx. Needless to say, these two go together, right? And we are going to rewrite this in the following manner, everybody. We have 1/cosine x and then sine x dx, right? This one is missing negative sign, so plug in negative in, negative out, and their product is 1, meaning times -1 divided by -1 in essence. So you have 1/u du, the negative sign outside remains. So you know the answer is a natural log. So minus ln u plus a constant, you replace it with cosine x, and that is fine. However, if you put this, if you go back to the concept of logs, and you say this one is the same of ln of cosine x to the power of -1, you should know that means the uh, reciprocal of cosine x, which is 1 over cosine, which is secant x. Okay, so these two are the same, and becomes ln of absolute value of secant x plus a constant. 6.1, the area of the region between two curves. Let f and g be continuous functions with f of x larger than or equal to g of x over the interval of a to b, closed interval. Then the area of the region between the two curves from x equals a to x equals b is. So the top one is the f function, the bottom one is the g function. So this is the area below f, this is the area below g, and this is the area in between. So we say area of region between f and g, area of the region under f, area of the region under g, and so we are going to write the integral of a to b f of x minus g of x dx. That is the area between f and g. Again, remember both functions are positive and f is above g. If we don't know f is larger, we have to go with an absolute value. This is the integral of a to b f of x dx and minus the integral of g of x dx from a to b. So these are the two vertical lines. So what do we do? The area of the region between two curves, here's the process. Number one, graph the two functions. Number two, find the points of intersection, set f of x equals g of x and so on. Number three, evaluate the integral. So this is called a typical rectangle or typical area. So this has a height h, this has a width, I like to call it dh because dh changes either to dx or dy, there's only two ways. If we sweep this across the x-axis, that becomes dx, the width is dx. But if we go up and down, it becomes dy. The area of a typical rectangle is, in this case, the way it is, because it's completely above, is y of t. T stands for the top. Y of the top minus y of the bottom times delta x. Please understand, h, the height, is the height of this point minus the y of this point minus the y of this point. The width is this much, which is an incremental width of dh, because we are sweeping it across the, along the x-axis, we call it dx. Therefore, I like to say this is a typical area, h times dh. You have to figure out what is h, you have to figure out what is dh. So the integral of a to b h dh. In this case, when one function is at top of the other one, we get y of the top minus y of the bottom times dx. If one function is to the right of the other one, we get x of the right minus x of the left times dy. I will show you as we go through some examples. And of course, this was the definition of an area under the curve using the Riemann sum. So the integral of a to b f of x minus g of x dx. All right. Find the area of the region bounded by y equals to x squared minus 3x plus 2, the x-axis, x equals 0 and x equals 2. Number one, we have to graph this, and I'm going to assume nobody has any problem with graphing that, okay? It's a parabola, it opens up, you can find the vertex x equals minus b over 2a and pick up a couple of pairs, and graph it, or you can even use a calculator. So what we want the area that is between this, bounded by this, x-axis, this one, x equals 0, the y-axis. In other words, we want the following, everybody. This is what we want. So what do we do? And that's the vertex. We draw a rectangular strip which has this width and this height. dA is the height times dH. Now the height for this one is y of this point, y of the top. T stands for the top. And B stands for the bottom. So y of the top is y of the function y equals 2x squared minus 3x plus 2. Y of the bottom is the x-axis. And the x-axis has the equation y equals 0. So this one is the top, this one is the bottom. And this is the width, dH is a dx or delta x. Now this rectangular strip, you go along the x-axis, you cover from where? From 0 all the way to 2. It covers the entire area. So y of the top is this function, y of the bottom is this function, and dx. So this is the height, f minus 0. So this function minus 0. So the integral of a to b h dh, the height is this, dh is dx, and a to b, we're going to go from 0 to 2 along the x-axis. So what do we cover as far as the x-axis is concerned? It's understanding this, which is the most important thing. Taking the integral by now, it's become a piece of cake. So this is 2/3 x cubed minus 3/2 x squared plus 2x from 0 to 2. 0 makes it nice and easy, makes it 0. Just plug in 2. 2 cubed, 8 times 2, 16 over 3. 2 squared, 4 divided by 2, 2 times 3 is 6, minus 6. Plus 2 times 2 is 4, and they add up to 10/3. So that's pretty easy. Find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x. F of x equals 2 minus x squared. Remember, x squared opens up, minus x squared opens down, and 2 takes it up, and g of x equals x is a line through the origin. So graphing this shouldn't be a problem. So we want to find the area bounded by that. That means we want to find this area, everybody. We want to find this area. So this is a typical rectangle. This rectangle sweep along the x-axis from here to here. So we need to find this point and this point. By the way, you can't have a horizontal rectangle because over here, the right side and the left side are both the same function. Over here, that's not the case, but over here, it so has to be a vertical strip. So you have to set the two equal to find the points of intersection. G of x equals x, meaning y equals x, replace it and solve it. So 2 minus x squared equals x. because this has a negative sign, let's take everything to the right. And we are going to factor when two numbers, the product is -2, the sum is 1, we get +2 and -1. I'm assuming nobody has any problem with factoring. So x is either -2 or +1. And so because g of x is x, that means this point has coordinates -2, -2. This point has coordinates 1, 1. That's the meaning of it. And again, uh, look at this vertical strip. This has to move left and right. So the height is the f function, the parabola, the curve, minus the bottom is the g function, the line. Say again, look at this point. Let me just actually put 1 point. Remember, the width is extremely small. So the very top is from the curve or f of x. The very bottom is from the line or g of x equals x. So that's why we have their difference. So dA is HDH. H is F minus G, Y of the top minus Y of the bottom, times DH, this width is dx. So Y of the top is this function, minus Y of the bottom is this function. And we are going to integrate this from the x coordinate of this point to x coordinate of this point, from -2 to 1. They happen to be the same, the x and y coordinates. So this is 2x, this is -1/3 x cubed, this is -1/2 x squared, from -2 to 1. You plug in 1, you plug in -2. I let you do the intermediate steps, and those are basic math. The answer is 9/2. Again, we have to go this way. We can't go this way. Find the area of a region bounded by the graph of x equals 3 minus y squared and y equals x minus 1. I hope you recognize this as a parabola that opens sideways because this is negative. It opens to the left. You can graph that, and this is simply a line, and you can easily graph both of them. So it's important to understand this is 3 minus y squared, and this is x equals y plus 1. The reason I'm writing it as that, because we are ultimately going this way. In a moment, you'll see why. We will need that later on. So typically, the area in between is this shaded region that we need. So we're going to call this 3 minus y squared g of y, and this one is f of y, the line. And each one, you can see that each one, let me just use a different, this is really x, this is x, okay? We just call it f of y and g of y, which means, of course, it's not a function. We are going to set them equal in order to find points of intersection. 3 minus y squared. So notice this is x, so is this one is y plus 1. So look at this one and this one. That's why we set it x equals that. So set them equal, and to solve, we're going to put everything on the right side. We're going to move everything this way, and we get y squared plus y, and 3 becomes -1 minus 3 makes it -2. That's the easy factoring. Y is either 1 or -2. So y is 1 here, y is -2. So if y is 1 and you put it here, x becomes 2. So this, it's easier to go with that. So y is 1, you replace it, and x becomes 2. So this point has coordinates 2, comma 1. Y is negative 2, put it here, you get negative 2, and 1 is negative 1. So that means this one, negative 1, comma negative 2. So we have this pair and we have this pair. Now notice, if we draw a rectangle which is vertical, the top is the line, the bottom is the curve. As you go around over here, the top is the curve and so is the bottom. That's why you can't go with that. If you go with a horizontal strip, now the right side, x up the right side is the curve, x up the left side is the line, comes from the line. Okay, so dA, which is HDH, is x up the right, x up this point, minus x up the left, x up this point. And so this is a G minus F, G minus F. So 3 minus y squared minus y plus 1. And of course, dy, y dy, because we're going to sweep it along the y-axis. So g of y, 3 minus y squared, minus f of y plus 1 dy. And now, because we are dealing with dy, when we want to take the integral, the limits are the limits on the y from negative 2 to positive 1. Okay, look at the y coordinates. The bottom is negative 2, the top is 1. So let's combine them. This is negative y squared. This is minus y. Let me just write this as minus y minus 1. And these two add up to plus 2. Negative 1/3 y cubed, negative 1/2 of y squared, plus 2y, evaluated from negative 2 to 1. Again, I'm going to leave it for you to do this. And we end up with 9/2. So this does have a couple of basic math, couple of steps of basic math. You plug in 1, you plug in negative 2. You can easily do that. It's really not a big deal. Find the area of the region that is bounded by the graphs of f of x equals 2x plus 1 and g of x equals x squared plus 1. Again, this is a parabola. It opens up and then shoots up by 1, right? It's just the same as y equals x squared up. And this is a line. So you easily can graph the two functions. And you can find points of intersection by setting them equal. You set them equal. We're going to bring everything to the same side. If we move, first of all, we can cross this out. If we move it this side and factor the x out, you get x equals 0 or 2. So there are two answers. And clearly, this is, you can plug in 0 in any of it. If you plug in 0 here, you get 0, 1. And if you plug in 2, you get 5. So you have 0, 1, and 2, and 5. So it's a really good practice to check with both of them. So let's evaluate the integral using HDH. And we're going to go with a vertical strip. And this vertical strip uses the y of the top minus y of the bottom. Y of the top comes from the line, which is f of x, or 2x plus 1. Y of the bottom comes from the curve, which is x squared plus 1. And this vertical strip has to go this way along the x-axis, which means it's going to go from x equals 0 to x equals 2. So y of the top minus y of the bottom. This is the height, f minus g. So this is f of x, this is g of x, by the way. So f is at top. See, everywhere from the beginning to the end, the f function is at top of g. That's how it works. And y of the top minus y of the bottom will do the job. So 2x plus 1 minus x squared plus 1. And we are going to evaluate this as follows. The integral of 0 to 2, 2x plus 1 minus x squared plus 1 in brackets times dx. So we get 2x minus x squared, and this is 2/3. This is x squared. This is minus 1/3 x cubed. 0 doesn't do anything. That's a good thing. You plug in 2, you get 2 squared minus 2 cubed over 3. This is 4. This is 8/3. 4 is 12/3. Minus 8/3 becomes 4/3. Very simple. Now, there's something interesting about this. We can do method 2. Notice this curve is completely on the right side of the line. So we can go with a horizontal strip, which means we can evaluate that from the bottom, which is 1, to the top, which is 5. So this would have h dh now is dy, and h is, let me see, what color do I want to use? Again, let me use red. It's x of the right minus x of the left. X of the right comes from the curve, x of the left comes from the line. So this is y, you want to solve for x, and this one you want to solve for x. So g minus f now. Y is 2x plus 1. Y is 2x plus 1. Y is x squared plus 1. We are going to solve for x. I hope you recognize this as y minus 1 divided by 2. And this one, y minus 1, you take a root. And there are two answers. Let me just be clear as to what happens here. Number one, when you solve the line for x, is very simple, half of y minus 1. When you solve for x, you get two of them, plus and minus. Please understand, this is the positive side, this is the negative side. Remember that. So you have to have the positive side of that. So when you solve for x, you get plus minus square root of y minus 1. And we use this one. Again, let me see if I have room here. So y is plus minus square root of y minus 1. We just use the positive one because this is positive. So h dh, dh is dy, h is x of the right minus x of the left. X of the right is the curve, and therefore it makes it square root of y minus 1. X of the left is the line, therefore it makes it half of y minus 1. So that's what we get. And the limits now are the limits of the y coordinates 1 to 5. This one, we can write it as y minus 1 to the power of 1/2. And with the help of a substitution, you let u be y minus 1, and du becomes dy, and then you have 1 over 1/2 plus 1 u to the power of 1/2 plus 1. So we've done this before. So again, the u substitution for this part, you let u be y minus 1, and then you should know you end up with 2/3. Okay, I'm going to leave it for you to do that. 2/3 y minus 1 to the power of 3/2. This is minus 1/2. Y gives you half of y squared. Negative 1 gives you minus y. And you're going to evaluate it from 1 to 5. Actually, evaluation takes a bit of time. It's not too big of a deal. So 2/3 y minus 1. Okay, remember y is 5. 5 minus 1 makes it 4 to the power of 3/2. Minus 1/2, half of y squared. Okay, that makes it 25 divided by 2, right? 1/2 minus y is 5. And then you do the same thing with 1. When you plug in 1 here, this becomes 0. When you plug in y here, 1 here, you get half of 1 minus 1, which is 1/2 minus 1, or negative 1/2. So this goes to 0, everybody. And this is 16/3. Because square root of 4 is 2 cubed is 8 times 2, 16/3. This is minus 15 over 4 because 5 times 2, 10. 25 minus 10 is 15. So we have minus 15, and the bottom is 2 times 2, 4. And this ends up being 1/4 because this is 0, and the product of these two is plus 1/4. When we put them together, you get to the same answer. And I hope you definitely get a chance to look at this one more time to see, in this case, we could use both methods, because on the one hand, this line is completely above the curve. On the other hand, the curve is completely on the right side. So you have two methods to do it. Finally, find the area of the region between the graphs of f of x equals 3x cubed minus x squared minus 10x and g of x equals minus x squared plus 2x. And of course, the first thing is to graph. You can use even a calculator to graph it. And so we want the region that is involved by finding the points of intersection and the area in between. So this is f of x equals 3x, this one. Maybe let's see if this function. Okay. It's 3x cubed minus x squared minus 10x. And this function, let me just say, this is the parabola minus x squared plus 10x. So you want to find points of intersection by setting them equal. These two are identical. You don't have to worry about that. You move this and you factor the 3x. X is either 0 from here, or x squared is 4 plus minus 2. So there are three answers. Minus 2, 0, 2. And of course, 0 is the easiest, would be this point, 0, 0. Negative 2, you plug it into this one or that one, it doesn't matter. Negative 2 squared by positive 4 with the negative becomes negative 4. 2 times negative 2 is negative 4. They add up to negative 8. So this is negative 2, negative 8. This is 0, 0. And if you plug in 2, also you get 0 because this is positive 4 with negative becomes negative. Positive 4, they add up to 0. So those are the 3 points. Let me erase mine. So it becomes clear that we have those 3 points and the coordinates are as follows. Now, what you should notice is that in this part, f of x, the cube function is at top. And for this part is the other way around, the parabola is at top. So I want to evaluate the integral, and dA is y of the top minus y of the bottom times a dx. And in this case, let me just use, let's see what color, okay, maybe this one does a good job. This is the top from the function, cube function, this is the bottom, but this one, the top from the parabola, this one, the bottom from the cube function. So therefore, you really have to go with an absolute value, which cuts it into 2 pieces. As we go from, so this is dx, as we go from negative to 0, this function is at top. So we put this one first. As we go from 0 to 2, this function is at top. So f minus g has this formula, everybody. So we are going to use this one from -2 to 0, and then the opposite of that, because the other one is at top, we want to use g minus f, which means minus 3x cubed plus 12x from 0 to 2. This is f minus g. Okay, so we get this one. But this one is g minus f, which is the opposite of that one. At 3/4 x to the power of 4 minus 6x squared from -2 to 0. Negative 3/4 x to the power of 4 plus 6x squared from 0 to 2. And you can plug in and do the work on your own. You should end up with number 24 as the final answer.